In this video, I'm going to walk you through the materials for Lab 2, which is drawing basic shapes in OpenGL. Now, this is the first lab in which we'll be using OpenGL. So before we continue, we need to download and build the project files. So if I just click on that link there, and the easiest way to get the files is if I just copy this command here, and go into, I'm on a Mac obviously, as you can see. If you go and use a terminal, or on Windows, this is a command window. So if you're on Windows machine, if you press the Windows button and press CMD, that'll bring up the command window. Okay, so I've just pasted that code in, and you can see it goes and downloads the project files. So if I open a file browser, you can see I now have my Lab 2 basic shapes. And if we go into this, I'll just quickly explain what this is. Okay, so source, this is perhaps the most important folder in the project file. Now this contains the code which we will be editing and compiling. Okay, external, now this contains some external programs which we're going to be using. You don't have to change any of those, and it's probably best if you don't change any of those. We've got a README file here. This is a markdown file which has the build instructions on it if you need to. Okay, so the first thing I'm going to do is I'm going to create a new folder. You can call it anything you like, but it's sort of traditional common to call this build. And now we're going to make the project files. So open CMake. If you don't have this, you need to download and install CMake. Okay, so what I'm going to do is I'm going to go to my files which I've just downloaded, if I can remember where they are. Ah, yeah, graphics. Okay, and I'm going to open that folder. So if I just go back to there, so I click on Browse Source. If I open that folder and click Open, and I click Browse Build and do the same, but this has to, I have to point it towards that build folder. So you can see we have the path is the same for both, but for the build one we have that additional build folder. So now I'll go down here and click Configure. I'm in Mac, so this is where we pick our IDE. Okay, you can see there's loads of IDEs. I'm going to use Xcode. In Windows, just select Visual Studio, and if I click on Configure, what it's doing now is it's having a look at my my hardware, and it's configuring all the options. This looks a bit scary in red, but don't worry about this. I just click Configure again just to confirm, and then I click Generate. Okay, so what has that done? Well, if I go to my build folder within the project files, you can see it's created an Xcode project, or if you're on Windows, this will be a Visual Studio project. What I'm going to do is just double click on this and open up Xcode. Okay, and you can see it here. Ignore all this bit down here. Okay, this is for some of the other things, so you don't have to pay any attention to this bit down here. Okay, but if I click on main, you can see I have a program. Now, to run this, I'm on Xcode, so I have to select the target, and the target for this lab is Lab 02 Basic Shapes. And if I select that and I run, or if I press Command B, that'll build, and I can run the program. Okay, and you can see it's shown a blank window. Now, if you're on Visual Studio, you have to right click on the name Lab 02 Basic Shapes. So there'll be a Project Explorer, and select it as default project. Okay, so as I run the program, you can see we're presented with an empty window. Okay, so the basic code gives you this sort of hello window, and what we're going to do is we're going to be drawing basic shapes in this window. Okay, I'm going to head back to the lab materials now. So we've done this, and we've presented with our hello window. So what we're going to do in this lab is we're going to set up all of the commands used to draw a basic shape to this window. Now, the first thing we have to do is create what's called a vertex array object. Now, this is a container for all the vertex attributes. Now, a vertex is for example, we're going to be we're going to be drawing a triangle, and a triangle has 3 corners. Those corners are known as vertices. Okay, so the first thing we do is I copied and pasted this code in, and where I've copied and pasted it in is just before we have a do while loop here. Okay, so I've just highlighted this do while loop. This is what's called our render loop. So all of our drawing commands are going to go within this do while loop. So before I have to draw anything, I have to define what I'm drawing. Okay, so we've created the VAO, vertex array object, and that's, as I mentioned, a container for all of the vertex attributes. Okay, so talking about vertices, so this is what we're going to draw. So here we have a triangle. Now in OpenGL, our window coordinates go from -1 to +1 in the horizontal and vertical directions. Okay, so we're going to be drawing this triangle, and it has 3 vertices. Okay, and these vertices are given by these coordinates. Okay, so what I've done here is we're going to define an array containing those vertex coordinates, and I'm just going to paste that in after we defined our VAO. Okay, so you can see we have an array of floats. I've called my array vertices, and now we have 9 floats within our array. What I've done is I've arranged it so we have our x coordinate, our y coordinate, and our z coordinate. So we have 3D coordinates. Our z coordinates are all 0 because for now we're only looking at 2D objects, and you can see I have those coordinates for the triangle vertices there. Okay, so that's just an array of those vertices. Now what we have to do is we have to somehow get these vertices over to the GPU. Now to do that, we use what's called a vertex buffer object. Now a buffer is just a bit of memory. Okay, so what we've done here is I've created what we call a vertex buffer. Okay, and this command, what this does, it copies across this data into the buffer. Okay, so that's been sent then over to the GPU. Okay. I'm sort of going over some of this quite quickly, so what I do recommend is you read the lab materials quite carefully. Okay, so what we now have to do is write a shader. Now a shader program, we're going to have 2 main shader programs. One's called the vertex shader and the other's called the fragment shader. Now the vertex shader, what we do is we feed in the information for the vertices of our triangle into the vertex shader, and what OpenGL will do is it will calculate which fragments or which pixels make up our triangle. So OpenGL will do this rasterization stage, so this works out which fragments are contained within the triangle, and then in the fragment shader, that's where we tell OpenGL what color each of our fragments is going to be. Okay, so start off with the vertex shader. Okay, so what I'm going to do is I'm going to create a new file. So it's just similar to do it if you're in Visual Studio. So I'm going to create a new file. Okay, C++ is fine. I don't need a header file. What I'm going to do is I'm going to call my file simple vertex shader. Okay. Okay, and this next bit is important. Make sure you save that within your source folder. Okay, else your program won't be able to find it. So you can see here we've got a simple vertex shader. Another thing I'm going to do is I'm just going to change that extension to vert. Okay, that's quite a common thing to do, just to ensure, just makes it easy to tell what sort of program it is, because it's not this simple vertex shader here. It's not a C program. It's what we call a GLSL program. Okay, so make sure we have that file extension vert. Okay, well, I don't need any of that. What I need to do is just copy and paste this code into my vertex shader. Okay, so what this does, this is an example of GLSL, which stands for OpenGL Shader Language. So first thing we have is we're going to feed into our vertex shader a position of each of our vertices of our triangle. Okay, so this vec3 means it's a 3-element vector, and it's going to be position. And in our main function, we're just going to output the GL position. Now, the vertex shader always has to output this GL position, and what this is, it's at the position of a vertex. Now, at the moment, we're not doing anything with the vertices. Now, in later labs, we will be changing the vertices in our vertex shader, but for now, we're just sort of we take in the position and we feed it out to GL position. Okay, so we also need a fragment shader. So again, I go through the same steps as before. So I'm going to create a new file, and I'm going to call mine simple fragment shader. Doesn't really matter what you call these, but you know, just makes sense to give them sensible names. Again, save it to my source folder, and again, I'm going to change the extension. Let's go on a bit. Oh, I can't see that. I'm going to change the extension in my file browser menu thing. So yeah, I want to use frag. Okay. Oh, that's gone a bit. Yeah. So just delete that. And another way of doing it is if I add that file. Okay. So you got to make sure that all of our files are in the right place. Okay. So here we have our simple fragment shader. At the moment, it's got something in it. I'm just going to delete that. And then I'm going to replace it with this code here. Okay, so this is our fragment shader. So remember, the vertex shader outputs GL position, and in the fragment shader, by default, it'll take in GL position. So we don't have to say we've fed in GL position, but we're going to output the color of our fragment. Okay, and at the moment, our fragment here we can see we've got a 4-element vector. Now this is RGBA. So this stands for red, green, blue, and alpha. So this, I've got one red, which is the maximum amount of red color we can have. So I've got one red, 0 green, 0 blue. So our triangle is just going to be displayed in red. This alpha means the transparency. So I've got it set to 1, which is the maximum. So it just means it's going to be a solid red triangle. Okay, so we sorted out the vertex shader and the fragment shader. Okay, almost there. Now what we need to do is compile the shader program. Now in our project file we have a class called shader. Now this contains a program called load shaders. Okay, you don't have to sort of read this or understand this. It's just know that this program here actually loads the shaders. Okay, so if I go back to the lab materials, if I copy that, and this can be pasted anywhere in our main as long as it's before the render loop, but I like to do it just after we've created the window, so I'm going to put it here. Okay, you'll notice we feed in the file names of our simple vertex shader and simple fragment shader here. Okay, so it's good to check, but we've got everything here. So at this point, our source folder should have main.cpp, the shader files, and the vertex and fragment shader. So I'm just checking that. Yeah, we got those there. Okay, so I'm now going to build and run it. Hopefully, fingers crossed, it runs. Okay, so we're presented, in this case, we're presented with a blank window. Something's gone wrong. Okay, this is good news for the purposes of this video because I can show you how we debug this. Okay, so down here, this is an Xcode. If you're in Windows, this will be a separate window. Okay, you can see I've got something problem here. I'm not quite sure what it is. Okay, so I've got my simple vertex shader, simple fragment shader, just making sure all of the names are correct. Oh yeah. The reason why, that's my fault. The reason why we haven't actually got a triangle yet is because I haven't told it to draw a triangle. Okay, so in this render loop, where it says this is where we draw things, this is where I'm going to have to put some code in to actually draw the triangle. So that was my fault. Okay, so to draw the triangle, now first thing we need to do is instruct OpenGL to use our shader program. So this shader ID, this is just an integer. This is what's used to identify our shader. So first thing we have to do is tell OpenGL to actually use our shaders. Okay. And now, remember we had that vertex buffer created before. Now we've got to actually copy that information across to OpenGL. Okay, so here we send the vertex buffer to the shaders. Okay, so what does this do? So GL enable vertex attrib array. This 0 here, this corresponds to this 0 here. So you can see the location equals 0. So we've told the shader to expect position coordinates. So here, this number, this 0 says, okay, we're going to copy across the positions of our vertices to that location 0. Okay, bind buffer, that just that's a command just to bind the buffer for OpenGL. And then we've got this GL vertex attrib pointer. Okay, so this tells OpenGL what sort of format our data is in. So if I just scroll back up, okay, so we have each vertex is represented by 3 coordinates, x, y, and z. Okay, so attribute is 0 again, so that corresponds to that 0 there. Size 3, we've got x, y, z coordinates. The type of our data are floats, so you can see we have GL float there. Normalize, no, we don't want to normalize. This is nearly always GL false. Stride, well, that just means what's the difference between each set of coordinates. So each set of coordinates follows straight on, so stride is 0. And offset, okay, our first value is in our array is the first coordinate, so the offset is 0. Okay, so that sends the data to the shader. Sorry, sends the vertex data to the shaders. Okay, so now I actually draw the triangle. Okay, so I'll just copy this code in after we sent the vertices to the shaders. Okay, so GL draw arrays. So this tells us this tells OpenGL, but we're going to be drawing triangles. So this is triangles. Just to remind myself. The 0 specifies, but the vertex of our first triangle is the first element within our vertex buffer, and 3 means we got 3 vertices. Okay, so if I just compile that, and if I run it, hopefully we can see a red triangle, and we do. Okay, so a bit of setup. Okay, so what have we done? We've created the vertex array object, we defined our vertices, we created the vertex buffer object, and we copied that across to the GPU. We also wrote our shader program and compiled it before drawing the triangles. So it's quite an involved process. I would say it gets, the more you do this, the more you get used to it. It does get easier. Okay, so we got a red triangle. What I'm going to do now is actually change the colors of our triangle or the vertices. Okay, so as well as the vertices, we can also send colors to our shader. Okay, so what I'm going to do here is after we define the vertex position, I've defined a similar array, and then this is an array of colors. Now here we've got 3 vertices, each of these rows, so I've got 3 colors. So the color of my first vertex is going to be red, the color of my second vertex is going to be green, and the third one is going to be blue. Okay, so whereas with the vertices we created a vertex buffer object, we also have to do the same for the colors. So that's just by pasting this code in here. Okay, very similar. Okay, you can see it's very, I think the only change is instead of the vertices we have a colors array, and I've called it color buffer. Okay, we also have to bind that and send it to the shader. So in the same way which we did the vertex buffer, I'm also going to do the color buffer. Okay, so this time with the vertices we put it into attribute 1. With the colors we're going to use attribute, vertices was attribute 0. With the colors I'm going to use attribute 1. Okay, so this means we're going to have to change our shaders. Okay, so what I'm going to do is I'm going to change our vertex shader program to be this. Okay, so go to a vertex shader. So I'm going to replace all that code with our new shader code. So you can see here we've now got another input attribute, and this is into attribute 1, and this is our colors. We're going to output, here we've got an additional output. So GL position gets output by default, but we also want to output our vertex color, which in this case I'm not doing anything to it, I'm just passing the color to the fragment shader. Okay, So in addition to changing the vertex shader, we also need to make some changes to the fragment shader. Okay, so if I go to the fragment shader, okay, so at the moment all we do is output the color red, but now what we want to do is we want to output, or we get the vertex color from the vertex shader and we output it. Okay, so you can see the vertex color was a 3-element vector RGB, so then we're expecting a 4-element vector, so I just stick the one on the end. Okay, so I think that's everything done. Okay, let's compile and run that program. Okay, so as you can see, we've got a bit more of a colourful triangle. So our vertices are the corners, remember, and we had a red corner, second corner was green, and the third corner was blue. And you'll notice what OpenGL does is it interpolates across, it fills in the gaps, so to speak. So as we go between the red and the green, you can see it interpolates. So it gives us quite a nice effect. Okay, so that's, in addition to sending the vertices, the coordinates to the shader, we can also send colours. Okay, and just finally for this lab, we're also going to add another triangle. Okay, so at the moment we've only got one triangle, so now I'm going to add another. Okay, so where we defined the vertices, so here we just had 3 rows of 3 elements. What I'm going to do now is define vertices where I've got 6 rows. So I've got 2 triangles, so the first 3 rows are the vertices of triangle 1, and the second 3 rows are the vertices of triangle 2. And I've also got a similar colour array here. So each row in the colour corresponds to a vertex. Okay, I don't need this second array there. Okay, so I think everything else is pretty much the same, with the exception of where we draw the triangles. Okay, so this GL draw arrays has changed slightly. So here you notice, okay, we had draw triangles. Our first triangle started at the first element in the buffer, and we just had 3 vertices. Well, I'm going to replace that. I've just pasted in the code. So the only change we've made is this code here, and size of vertices, so that's the size of our array. So our size of our vertices array, so how much memory do all these take up? And I divide that by 3 times the size of an individual float. Okay, so that gives us the number of vertices we have. So what I'm going to do is I'm going to run this. Replace. And you can see I've got 2 triangles. So 1 red triangle, 1 blue triangle. If I go back to my arrays, you can see, so the first triangle has these vertices, and the first triangle, all of the vertices are red. So hence it gives us a red triangle, and the second triangle, all the vertices are blue. So it gives us a blue triangle.